Good morning, fifth graders. Today we are on page 223 of your student journal, and we are going to be continuing with what we started yesterday. So we are going to be continuing with finding volume in multi-step word problems. So our objective today is, today I will solve multi-step word problems involving volume using the standard and metric systems. Okay, we have been having these extremely long objectives and goals now for 6 lessons. But pretty much we know that a multi-step word problem means you're going to have to do more than one step, 2 to 3 steps. And then all of our word problems will have volume in them. And we're going to be using the U.S. customary system or the standard system as well as the metric system. So there's really nothing new in our vocabulary to review, except for the U.S. system. Remember I said that all of these measurements need to be in your head. You are expected to memorize all of those measurements. So to help you memorize all those measurements, you are going to be practicing writing drawing our gallon man picture. So ready? Gallon man has 4 queens, each with 2 princesses, each with 2 cats. And remember, I told you that I still use this picture to help me make conversions. So once you do this picture, there's so much information you can gather from this. I can say there's 1, 2, 3, 4 quarts in a gallon. I can say there's 1, 2, 3, 4, 5, 6, 7, 8 pints in a gallon. I could say there's 2 pints in 1 quart. I could say there's 1, 2 cups in a pint, or 1, 2, 3, 4 cups in a quart. There's lots of facts that I can pull out of this one picture. Okay, looking at our steps today, step 1 says we're going to be reading the problem and making a plan. Step 2, we're going to identify the units. And remember, we're looking, is it US units or is it metric units? Step 3 says we're going to create a conversion chart. We're only going to do that if it's US system, and along with our conversion chart, we're going to draw a picture. Now, if it's the metric system, though, we are not going to use our conversion chart. We're going to use King Henry died by drinking chocolate milk. That is going to be our strategy. And then step 4 says we're going to refer to our conversion chart to get the needed conversion, and 5, solve. All right, so ladies and gentlemen, I'm going to jump right in and get my problems done if you want to watch. My first problem says, Sophia made 7 1/2 gallons of lemonade at a cost of $35.44. During the football game, she sold lemonade for $1.25 per cup. How much money did she make? Okay, so what I see right away is I see gallons and cup. So I know that I am using the US system. So if I'm using the US system, I'm going to draw a picture and use a conversion chart to help me. So my picture is gallon man has 4 queens, each with 2 princesses, each with 2 cats. Okay, and this kind of silly picture is going to help me make my conversion chart then. So my conversion chart is, in my word problem, they talk about gallons and they talk about cups. So what can I pull from my picture? Well, I see that 1 gallon is equal to 2, 4, 6, 8, 10, 12, 14, 16 cups, which tells me 2 gallons would be equal to 32 cups, which means 3 gallons would be equal to, let's see, it means I'm adding 16 each time, 48 cups. Okay, but I have to get all the way to 7.5. I might actually just jump to 7 first. Let's go to 7 first. So what's happening here? 1 times 16 is 16, 2 times 16 is 32, 3 times 16 is 48. So I need to figure out what 7 times 16 is. I can't do that in my head, so I'm going to come over here and do some scratch work. So 7 times 6 is 42. 7 times 1 is 7, plus 4 is 11. So 7 gallons has 112 cups in it, but it says 7.5 gallons. I might use my picture to help me with that. So if I look at half my gallon, how many more cups am I going to add? 2, 4, 6, 8. So I'm getting 120 cups when I added those extra 8. So that this picture is really helpful. It gives me a visual plus a lot of information. Okay, so what I'm going to do in my word problem is I'm going to cross this off and say 120 cups. Okay, now because I have only one measurement in the word problem, I can just jump right in and I can actually solve this now. So what do I see? I see it says Sophia made 120 cups of lemonade at a cost of $35.44. During the football game, she sold lemonade for $1.25 per cup. Okay, so let's figure out how much she made just at the football game. So that means it was 120 times $1.25. So that's a multiplication problem. So let's see. 5 times 0 is 0. 5 times 2 is 10. 5 times 1 is 5 plus my 1 is 6. Okay, let's go to our next one. 2 times 0 is 0. 2 times 2 is 4. And 2 times 1 is 2. Oh, now I need 2 placeholders. 1 times 0 is 0. 1 times 2 is 2. And 1 times 1 is 1. So when I add all these up, and remember for when I multiply decimals, I have to move the decimal over. I'm seeing that when she left the football game, she had $150 in her pocket or in her bag. But that's not actually how much money she made, because to figure out how much money she made, you have to subtract how much she spent. So this is why we call this a multi-step word problem. So she brought home $150, but she had spent $35.44. So I need to come up here and subtract what she'd spent, and that will actually tell us our true profit. Now remember when I add and subtract decimals, friends, that I have to line up my decimals. So 0 take away 4 is not possible. So I have to come all the way over here and borrow. That becomes a 10, but then when I borrow it becomes a 9. That becomes a 10, but when I borrow it becomes a 9. So I have 10 take away 4 is 6. 9 take away 4 is 5. 9 take away 5 is 4. 4 take away 3 is 1, and 1 take away nothing is 1. So her actual profit is $114.56. Okay, notice again, we talked a lot about how much work these problems entail. Lots and lots of effort. All right, let's look at my next one. At the carnival, each baby will receive 1 balloon. Josie purchased a 2.5-liter helium tank. Each balloon was filled with 25 milliliters. Josie used all the helium in the tank to fill the balloons. Right before the carnival, 4 balloons popped. How many balloons will she have at the carnival? Okay, what I noticed right away is 2.5 liter and 25 milliliter. So that tells me that my system that I'm working with is the metric system. So for this problem, I'm going to use the strategy of King Henry died by drinking chocolate milk, and my base measurement for volume is liters. Okay, so I want to change one of these. I might change the 2.5 just so I don't have to work with fractions. The only problem is when I write 2.5, remember I need a decimal, so I'm going to say instead of 2.5, I'm going to say 2.5, which is the same. So 2.5 liters equals how many milliliters? That's what I want to convert. Well, let's see. If I go from liters to milliliters, I go 1, 2, 3 spaces to the right. So I might need some extra room here. So if I move that decimal 1, 2, 3 spaces to the right, I am getting 2,500. Okay, so let's come up here and change that in our word problem. Let's change it to 2,500 milliliters. Okay, now that I have only one measurement in my word problem, I can actually attack the word problem itself. So let's read this now. At the carnival, each baby will receive 1 balloon. Josie purchased 2,500 milliliter helium tank. Each balloon was filled with 25 milliliters. Josie used all the helium in the tank to fill up the balloons. Right before the carnival, 4 balloons popped. How many balloons will she have left at the carnival? So I need to take how much helium she had and divide it into groups of 25, because that will then tell us how many balloons she had. So I think I'm just going to use long division for this. There are different strategies, but this is what I'm strongest at. So 25 cannot fit into 2. 25 can fit into 25 one time. 1 times 25 is 25, and when I subtract, I get 0. When I bring down, I get 0 again. So 25 can fit into 0 times. 0 times 25 is 0, and when I subtract, I get 0. And I think you're seeing what's going to happen here. I'm going to end up with all zeros. So she can divide her 2,500 milliliters into balloons for 25 milliliters each, and she's going to be able to fill 100 balloons. Okay, we are still not done though, because what did the problem tell us? She filled 100 balloons, but right before the carnival, 4 balloons popped. So how many balloons does she actually have? That I don't need to show work for, because I could easily do that in my head. So 100 balloons she had, 4 popped. She ends up having 96 balloons for the carnival. Okay, again, I do realize all the effort that goes into attacking these problems. Okay, so ladies and gentlemen, let's try some together. We're on page 224, and our first problem says, Grace has to make 20 centerpieces for the wedding tables. Each centerpiece requires 2 cups of sand. If sand is sold in boxes of 2 quarts, how many boxes will Grace need? Okay, so what do I see here? I see cups and quarts, which tell us it's a US system problem. Okay, so we're going to start with our picture then. Gallon Man has 4 queens, each with 2 princesses, each with 2 cats, which stands for our cups. Okay, and my problem has cups and quarts in it. So that's what our conversion table or chart's going to have, is cups and quarts. Okay, so what do I see here? I see that 1 quart has 4 cups in it. And I see that 2 quarts has then 8 cups in it. So I could change my 2 quarts to 8 cups. I think I might do that. So let's cross that off and say 8 cups. Okay, so now that my problem only has the measurement cups, now we can attack the problem. Ready? Grace has to make 20 centerpieces for the wedding tables. Each centerpiece requires 2 cups of sand. Okay, so I might stop right there. If she has to make 20 centerpieces and each one needs 2 cups of sand, I know that 2 times 20 is 40. So she needs 40 cups of sand. Isn't that what that's what she needs? Okay, I circled it, but we're not quite done yet. Okay, ready? Our next part says, if sand is sold in boxes of 8 cups, how many boxes does she need? Well, so that tells me that if she gets 1 box, she's going to have 8 cups. That's not enough. Well, if she gets 2 boxes, she'll have 16 cups. That's not going to be enough. 3 boxes, she'll have 24 cups. 4 boxes, she'll have 32 cups. And 5 boxes is going to get her 40 cups. And that's what she needed. So she needs to order 5 boxes. Okay, ladies and gentlemen, let's try one more. Gabriel and 5 friends are planning for a pizza party, and they have 2 1-liter bottles of juice. Each of them will drink 300 milliliters of juice. How many milliliters of juice will be left over? Okay, so what jumped out to me at this problem is I see the word liter, milliliter, and milliliter, which tells me we are using the metric system. Okay, so our strategy for metric system is King Henry died by drinking chocolate milk, and our base measurement is liters. Okay, so in this problem, if you notice, we don't really get to choose because the question says how many milliliters of juice will be left over, which tells me they want me to work with only milliliters. So I have to get rid of the 2 1-liter bottles. That's what we need to get rid of. So 2 1-liter bottles is pretty much just 2 liters. So we want to change 2 liters equals how many milliliters? Okay, which means 2 decimal. So I'm going to go from liters to milliliters, which means let's go from liters to milliliters. So what did we do? We went 1, 2, 3 to the right. So let's go 1, 2, 3 to the right. So I'm going to say 2 liters equals 2,000 milliliters. Okay, so let's cross this off and write what they have. Okay, so again, now that our word problem has only 1 measurement in it, now we can actually solve it. So let's read it. Ready? Gabriel and 5 friends. Okay, I'm going to stop right there because when I see Gabriel and 5 friends, I know they're trying to trick me. Gabriel and 5 friends means 6 people. That's what that tells me. 6 people. So 6 people are planning for a pizza party and they have 2,000 milliliters of juice. Each of them will drink 300 milliliters. Okay, I'm going to stop. So if 6 people each drink 300 milliliters, what is 6 times 300? Well, I know 6 times 3 is 18. So I know it's 1,800 milliliters. So that's what they're going to drink. So let's continue reading. How many milliliters of juice will be left over? Well, if they had 2,000 and they drink 1,800, doesn't that tell me there's going to be 200 milliliters left? And that is our answer. Okay, ladies and gentlemen, I know these are a lot of work. I also know you can do it. So today you have quite a lot of pages to do, 225, 226, and 227. Have a nice night.